Ladies and gentlemen, today's topic is fundamentals of Dockers, and it's presented by one of my dear friends, Satyan, and he is an expert in Dockers, Kubernetes, virtualization, and much more. So, welcome to Texi Tutorials.
Hello students, welcome to this class. And in this class, we are going to talk about what is Docker, because Docker is a very popular topic and subject these days. My introduction, my name is Satyan. I have 20 plus years of experience in the software engineering field. Most of my experience has been in large scale distributed systems, cloud and virtualization. So first of all, why this session? Dockers, containers and Kubernetes, they are very widely used technologies. Any large companies, any small companies, they use these technologies because these technologies, it enables you to write highly scalable applications very quickly and very easily. And again, then the last but not least, and the biggest reason, because there are lots and lots of jobs which requires Dockers, containers and Kubernetes knowledge. Right? If you just go and search in LinkedIn, and in last 30 days, there were 3,000 jobs posted in India with the keyword Dockers, and more than 15,000 in US, right? And this is also among this coronavirus scare which is going on currently, right? So imagine if it's a regular normal time and if the market is doing good, imagine the number of jobs, right? So that is one of the biggest reason for full stack programmers job interview. Definitely people will ask you whether you know this or not, and you are expected to know. So that's why we are taking this session. And again, if you haven't used Docker at all, you don't know anything about Docker, this is the perfect class for you. You don't need to have any background. We are going to start from the very basic, and we will take baby steps and build things as we go along, right? And if you are expert Docker user, this will serve as a refresher for you. So let's dig into it. So what are we going to cover in this series of classes? We'll cover, why really Docker is needed, because even when Docker was not there 10 or 15 years back, the softwares were still being produced and the companies were still up, fine and running, building large scale software. So what was the need of Docker and why is Docker? We are also going to look into what exactly is Docker. What are the different components of Docker? And we will also see, along with Docker, you always hear the word container, right? So we'll understand what exactly is a container. And then we will also see behind the scene what exactly is happening. What are the technologies and what are the concepts which make Dockers and containers possible. We will look at some basic Docker commands, and we will also look at how to create a Docker image. So overall in this class, it's going to be a fun, interactive and hands-on class, right? So we are not just going to talk about theory, but we will do practicals as we go along. Now let's see, first of all, why is Docker needed? So let's look at a typical flow to install any software, right? So you download an installer, you run the installer, and when you run the installer, there could be two outcomes. Either you will run into an error or the installation will be successful, right? Now, if it's a complex software, then more often than not, you will run into an error, right? You resolve the error. After you resolve the error, you might run into another error. Again, you resolve the error, and you keep repeating that cycle until your installation is successful, right? And once installation is successful, you may have to go and do proper configuration, modify some configuration files, and restart your software. And then eventually, your application is ready to run, and you are ready to use your application. It's a very involved process, right? And software installation, normally it happens only one time. So it is taking your productive time away, right? And as an application programmer and a developer, why do you really need to spend so much time in installing and configuring your software, right? So let's see how this happens with a live example. I'm going to install a Redis server on my local machine. And for those who don't know, Redis is a highly scalable in-memory database that many web applications, they use it today, right? So let's go to the Redis page, download page, and it lists out some simple steps for installation. So let's try to run the first command. If I run that first command, let's see what happens. And there you get, it says that the command not found, wget command not found, because on my local machine I do not have the wget program installed. That's why I ran into this error. To install Redis, wget is one of my dependencies, right? And I have to first go and download this wget, right? So if, as you see, that that installation is not just single step, and it's not that easy. Let's see how Docker can help in this. And to use Docker, first we will have to go ahead and install the Docker on our local machine, right? So for that, first you have to sign up at Docker, right? So let's go there. I have already signed up for the account, but what you need to do is that you need to go ahead and sign up. It will ask you for a Docker ID, which is nothing but user ID, and then your email and password, right? Once you sign up, what you do is you go back to docker.com and you go to get started, right? And we need to install the desktop version of the Docker. Since I'm using Mac, I'm going to download it for Mac, docker.dmg file. I have already pre-downloaded and pre-installed Docker on my machine, but you can go ahead and download that DMG file if you are running Mac. If you are running Windows, there is steps that you can follow, which once you go to the Windows page over here, it will list out the steps. But go ahead and install. And once you install on your desktop machine, what actually it is doing is it is going to install Docker client and server on your machine. And as you see here where my mouse pointer is, there is this icon here, right, which looks like a well and with some containers on top of it. So that's, you should be able to see that symbol after the installation, right? Let's see. So for me, the Docker desktop is already running. Let me just try to restart and see what happens. Right. So when I restart and when you try to install, you will also see something like this. This containers, they are little containers, they are dancing, and you will see Docker desktop is starting. In few seconds, you will see that it is installed and up and running, and you will see it green. Right. Just give it a few seconds. Okay. So now you see Docker desktop is running, and once it is running, if you type this command, it will tell you that what it installed and what is running, right? So when I do the Docker version, it tells me that Docker client is running, what is the version, and blah blah blah, some other stuff. The same way it will give you detail about the Docker server, right? So that Docker installation, it installs Docker client and server on your machine. Let's just try to install the same Redis server using Docker, and let's see what happens. Docker run Redis, and if I do this, let's see what happens. So over here, what it did really, it said that it is ready to accept connections. Basically your Redis server is up and running and ready to use in few seconds or few minutes, right? In this case, it was very quick just because I had a Docker image already installed on my machine. So let me show you once more. Let me remove that image. Redis, right? Okay. So now that image was gone. I'm also going to remove another image that I'll be using later on for the class. Okay. Now let me run that command, docker run redis. right? So it is going to take couple of minutes. What it is doing is actually it is going to the Docker hub, it is downloading the Redis image, and then it will install and start Redis server, right? So it says ready to accept. Still it took around a minute, right? So as you see, with Docker, you are basically ready to run your server in about a minute, right? So that is the fundamental problem that Docker solves, right? It makes the installation very, very easy. You don't have to worry about dependencies and configuration, right? Isn't that cool, right? As an application developer, why should you worry about really installation, right, of your software? You should spend more time in really writing the application rather than figuring out the installation part, right? So that's the fundamental problem that Docker solves. The next question is, what exactly is Docker, right? You might hear your colleagues, you might see on a job posting that Docker is required. Now, actually, what they mean by Docker is the Docker ecosystem. And Docker ecosystem has different components: Docker client, Docker server, which is just what we downloaded on our machine. Then there is Docker hub. Then there are Docker images. There is something called Docker compose, Docker machine. Each of these components, they have different purpose, and we'll talk about some of this today. Now let's run another example, hello world, right? Like in any other programming language or anything that you learn new, it's a very popular thing, hello world, right? So Docker also has this hello world. And try to understand exactly what is happening behind the scene. So I'm going to stop this Redis server, and then let's run this image, or let's run this command, sorry, docker run hello world, right? So what it did, that image doesn't do much other than it says that hello from Docker, and it gives some other messages, and we'll see it in a second, right? So let's see what actually happens, right? So docker run hello world, when I type that command was basically intercepted by it's the Docker client, right, where I run the command docker run hello world. So the command went to the Docker client, and Docker client, it doesn't have lot of logic inbuilt. All it does is it passes on the command, parses the command, and then it sends the command to the Docker server, right? Now Docker server, what it does is it looks at the cache, image cache in the local computer. And what this image cache is, that it is basically, let's say if you have downloaded some Docker image before, then it gets stored in the local image cache, right? So it looks for hello world image, whether it is already there or not. It looks for it, it sees that it is not there, so it contacts the Docker hub, right? And Docker hub certainly has this hello world image. So it downloads the hello world image, put it in the local cache, and then it runs, right? So that's what really happened. Let's look at our terminal, the messages, right? See, when I typed in docker run hello world, initially it said that unable to find the image hello world locally, right? Then it says that it is pulling the image, then it downloaded the image, and then it prints the message, right? So if you see this message, it really tries to explain you exactly what are the steps that Docker took. Docker client contacted the Docker daemon, and Docker daemon is nothing but Docker server. Docker daemon pulled the hello world image from the Docker hub, right? And Docker daemon created a new container. After it downloaded the image, it needs to create a container, right, out of that image. So that's what it did. And then after that, it really ran that container, and the output from that container, it was sent to your terminal. So that's what happened, and that terminal is this, what we are looking at currently, right? This output, right? Okay, So that's that's a basic example, and we talked about exactly, when you run any Docker command to run a container, what is happening. Look at what exactly is happening behind the scene, right? Because to make things simple, so simple, right? Installation with a single command, there is a lot of things happening behind the scene, right? And to understand that, let's look some high level concepts, right? So in your typical machine or your computer, you have some hardware, and that hardware is your hard drive, your network card, your network interfaces, your CPU, which is really the brain of your computer, and it provides the processing power, and then also the memory, right? And then on the top you have some applications running, right? You might have database applications, you have web browser, you have your own applications. They are running on your computer, and all these applications, they need some hardware resources from your machine, right? They need network, they need hard drive space, they need processing power from CPU, they need memory to put things into memory cache, so that the application runs very fast, right? So what is it that controls and governs all those access? So there is something called kernel, right? So kernel, it sits in between all your applications and all this hard drive or hardware resources on your machine, right? Which governs or which controls the access to all these applications, right? And coordinates also. Okay. So there are two concepts which makes the Docker technology, Docker and container technology possible, right? One is something called namespace, right? So namespace is nothing but it isolates the resources per process. And second one is the C group, which limits the amount of resources that each process can use, right? So let's look at what it is, right? So for example, let's say in the previous slide we saw this MongoDB and browser and kernel and other part, right? Let's say if I put MongoDB in a separate namespace and the browser in a separate namespace, then what kernel does by using the namespace is that it creates a separate whole execution space, isolated space for MongoDB. And MongoDB, it sees that there is some specific hardware resources it is allocated for it, right? And also how much it can use, right? So all those that is controlled by the control groups. And the same for browser also, it is allocated a different space, right, for its own. So what that means is, for example, let's say if MongoDB is writing to some file, right, and creating that file in the hard drive, the browser will not be able to see that hard drive, even though they are running on the same machine, right? If you are using namespace, separate namespace, one for MongoDB and one for browser, the browser will not be able to see any file written by MongoDB browser on the hard drive. So for example, let's say if we are not using namespace, right, then MongoDB is creating a hard drive, creating a file on hard drive, and if it has a proper read, write and execute permission for any other process, then even browser or any other application will be able to see that file or read from that file. But with namespace, they cannot do it directly, right? There are other mechanisms how to do it and how to share, but normally they cannot do it. And this is the two concepts, namespace and control groups, which makes container technology possible, right? So you can so in container also, you can just imagine that this is one container, right? It has its own resources, and this is another container which has its own hardware resources. So this, if you see the previous slide, I mentioned that it is supported on the Linux, right? Now it is supported on the Linux, then how Docker is possible on Mac and Windows, right? Because some of these concepts are not supported by Mac and Windows. So actually, when I downloaded Docker, right, so it downloaded something called virtual machine as well, Linux virtual machine. So the Linux virtual machine, it sits on top of the kernel, right, and it provides all this namespace and control groups concepts, and all your application, then any application which runs inside this virtual machine, it can take advantage of the Docker technology. So let's see, when I let me show you. If I type the Docker version, right, even though I'm running my using Mac, if you see, if I type Docker version, it says that the OS, well, let's look at the server part, right? So it says that I'm running Linux, right? It did not show me that I'm running Mac. It shows that I'm running Linux, right? That is, so really Docker server is basically running inside a virtual machine. I hope this is making things clear for you guys. So let's see what is an image and what is a container, right? So image is nothing but snapshot of a file system with some startup command in it, right? So let's understand what exactly it is, right? So when I had that Redis image, so in the Redis image, what it had is, it had some Redis, it has Redis plus some other dependent libraries, and it had some initial startup command. That's what that image contained, right? And what I can do with that image, when I run that image, right, it creates a container and it starts the container using this startup command, right? And it tries to put that image into basically cache or memory of your machine, right? So the container is, consider that you have an executable or a program on Windows, right? And when you want to run it, that executable or binary, when you run it, it becomes a process, right? So whatever is the relation between executable or binary and a process, the relationship between image and container is same. You can create multiple container from the same image. Let me show you one example on that. So there is some other image called busybox, right? Busybox, and I'm going to do ping google.com. So it will do nothing, not much, but yeah, so it is unable to find the image locally. It downloaded the image and then it is running this command. Now if I go to this other terminal, I can run the same command, docker run busybox ping google.com, and when I do this, you see I use the same image, but I have two different containers using the same image. And if I want to see that how, let me show you how. I'm going to create a new tab, and if I docker ps, so it shows me that I have two containers running using the same image. These are the container ID and they both are using the same image, busybox, right? And you can see that they were started just a few seconds ago, right? So now let me stop one of them and then run this command again, right? Now you see only one of them. And if I even stop this, you will not see anything. Container with an image, you can run multiple containers. So now we saw what is happening behind the scene and what are the concepts that make container and Docker technology possible, right? Let's look at some simple operations or basic commands for the containers. So first we'll see list containers, right? So right now I don't have anything running, so you will not see anything. Now let me start that one of the busybox container again, image again, and if I run it now, so it will show me this. It will show me whatever is the running containers are. If I do this, right, what it will show me all the containers, not only the containers which are running currently, but all the containers that I ran, right? It will show me the history. So for example, if you see the first container over here, it shows me that it is the status up 30 seconds ago and it is still running, right? And then you will see this name. So it tries to give the name to the container, right? And these names are randomly generated, and it will show the container ID also. So with the container ID, we'll talk about it. Container ID is very similar to process ID, and you can use it to run other commands, right? And if you see the other containers other containers in this list, it says that, see, this was the busy box that we ran a couple of minutes ago, and you can see that it was exited. If I do this part, let's say the other thing that I wanted to show you was, so we saw this command, now running a container, right? So let me show you again. We saw a few times that when I run this container, it is just running, right? But behind the scene, what actually it is doing is that the run command, it has two components to it, two parts to it. So one, it creates container out of the image. So when I run this command, docker run busybox ping google.com, it takes this busybox image, it creates a container out of it, and then it also starts the container with some startup command, right? And when I pass a command like this, ping google.com, that is I'm overriding the startup command which is already there in the busybox image. Instead of creating and running a container in a single step, I can do it in two step also. For example, there is this thing, let me show you. Let's stop this busybox image, and what we can do is, let's use the Redis, right? So I can say that docker create Redis. So it already had a Redis image, so it did not have to download, but what it did, it created the container out of it, and then it created this long container ID, right? Let's see if the container is running or not, right? So container is not running. Now what I can do is that I can use the start command to start this container, and I will have to pass the container ID. So I don't have to pass the complete, I will have to pass initial few digits that can identify it uniquely, right? So once I start it, okay, let's see what happened. I should be able to see docker ps, see Redis container, it basically started 52 seconds ago, right? What I can do is that now I can stop this container. So look at the status here, it is showing me up and it is running, right? What I can do is that I can stop, right? And again, if I do ps, it went away, right? And if I want to see again the same container, if I do ps -a, look at this, what was the affectionate boss, right? It said that exited 8 seconds ago, and I can restart again, right? So for example, I can start it again, right? And let's see, docker ps minus, rather than ps -a, I'm going to do just ps, so you can see only that container. Now let's say if I want to permanently kill this container, how do I do it? So to permanently kill the container, I use the docker kill command, and then right, let me see now, do I do it? No, right? Now let me try to start this container. right? And let's see, did it really work? Did it start? Yeah, it did start, right? So you can do that now. Yeah, so if I kill it again, docker ps, yes, and then docker ps minus a, if I do this, it will show me everything that it exited and other part, right? Now the one thing that I wanted to show you was that why, even though all these containers I had already stopped it, why are they still showing up? Because what happens is that Docker, it maintains a table where it shows that what were and it maintains the history of all the containers with the status and everything, right? How do I do that? So what I can do is that I can clear that up by running this command, docker system prune, and it will ask you that. So what it will say is that it will remove all the stopped containers, all networks not used by at least one container, all dangling images, all dangling build cache and everything, right? So all the resources that being used by stopped containers, it will release it in case if they are still not cleaned up. Okay, it will not impact the running containers though. Okay, so look at this. Now if I run the docker ps command, it doesn't show anything, right? So that's there. Now let's say the other part I wanted to show you was that, for example, if I run the hello world image, right, it is, see, the hello world image is, it was there, so it did not have to go and download. Now let's say either you are running out of space, or you decide that you don't need to have this image anymore, right? So in that case, you just want to get rid of completely, delete this image. So for that, what you need to do is that you have to use this command, docker rmi remove image, and say hello world, right? Okay, so here it is giving me a response, error response, right? Because it says that conflict, unable to remove repository reference hello world, must force, right? And the reason why? Let's see, where is the reference? Because if I run this command, see, you will see this hello world in that table still, right? So first I have to remove that reference from the table, I have to run this command. So once I run this, it is removed from that table, right? And after that, if I run the image, sometimes it takes a little bit of time to clean up that table where it maintains all the stopped containers, info about all the stopped containers. That okay, this time it was successful, right? So we removed the image, and now again, if we run the command hello world, see, it did not find the image locally and it had to download. That means with the remove command, the image was really gone from even our cache and everywhere. If you want to go and get access to the shell, right, inside a container, how do you do that? Redis command, docker run redis. Let me get the docker ps. I got my ID for the Redis, and then what I do is that docker exec it, then my ID. I need the Redis part. Docker exec it paste and sh, right? If I do this, so now I'm inside really the Redis container, right? I can run, okay, I can run different commands, right? That, let's see if there is anything here. Yes, look, it shows me what is inside that Docker container, right? The Redis container, it has bin, data, and all these different directories, right? So this is how I can get inside a container. If I type exit, I get out of that.
All right, folks. So in the next video of this series, we will look at creating your own image using Dockers. And then we will look at a small project using Node.js. And we will try to understand Docker Compose and multiple containers. And that will be the next video. And I hope you learned something from this video. And if you did, please like, subscribe, and provide a nice comment. And I'll provide a link to the next video here. Thank you.